Hi everyone, here is a short demo of our final project, Secured Content-Based Routing, we did as part of the course EE533. In the design, incoming packets are highly encrypted. It is decrypted in the system to inspect the content and determine the destination. It is encrypted back before routing to the destination. This allows consumers to define the type of messages they are interested in. Message producers do not keep track of consumer population and can simply inject messages in the network. The design essentially consists of a processor and an interconvertible FIFO. Instructions for the processor is written in a high-level language like C, which is then converted to the assembly code and then further to the machine and is finally fed to the processor. Incoming packets are collected in FIFO and content inspection is done in the processor to generate the destination IP, which is then padded back to the packet and is routed out. The payload of incoming packets is inspected for two things: one, content, and two, user ID. And if found a match for valid user ID, the corresponding destination IP is padded to the packet and the packet is sent out. In case, while inspection of the packet, if the user ID is found to be invalid, then the packet will not be sent out, but will be dropped.
Getting into the design implementation, I'll first explain RSA, which we have implemented in software. Here N0 is a sender node, and we'll first show key exchange between N0 and control node. N0 generates a pair of keys, public and private, and a 64-bit symmetric key, and it sends it across to the control node after encrypting it. Control node decrypts the symmetric key and it stores it. So now we'll do the same key exchange for node N1, N2, and N3. Node N1 is ready to receive the key. Node N2 is ready to receive the key. Node N3 is ready. And now node N0 will send the key to all the three nodes, and the key exchange has happened successfully.
Before setting up the content-based router, let us check the connectivity of all the nodes and measure the performance by pinging to all the nodes. As you can see, the round-trip time of our processor is around 0.19 milliseconds. Now, let us initialize our router. Here, we are writing the contents to be matched for all the destination nodes, the destination port ID, and the symmetric key into the processor. The initialization is now complete and we can start sending the packets. We will start the TCP dump session on all the receiver nodes N1, N2, and N3 to see the received data. We will also source a script called monitor.sh which monitors the destination to which all the packets are routed and outputs a file which is used by the real-time graph plotter. Now we are going to start the real-time graph plotting. The sender can look into the routing table which gives information about the tag associated with each destination node. All the data that are sent should start with the tag. When there is a match in the tag, the router routes the packets to the corresponding destination address. Now we are sending data to the node 2, and this is reflected in the real-time graph plotter as you can see. By sending more data, the graph goes up. By changing the tag, the data arrives at a different node. Now we are sending data to the node 1. Now we are sending data to the node 3 by using the tag of the node 3. In this way, we have achieved the content-based routing. All the data packets are encrypted before sending with a 64-bit key and is decrypted at the destination. The real-time graph plotter monitors the count of the packets received by each destination node.
Now, we would like to justify why our system is superior to software content-based routers. We are comparing our secure content-based router with that of the OpenFlow switch. OpenFlow switches are essentially similar to software content-based routers, and hence the comparison. It is a network topology that separates control plane and data plane of networking switch, and these switches are controlled by software controllers such as POX and NOX. With this command, we are setting up OpenFlow network with 3 hosts, an OpenFlow switch and a controller. On typing the command nodes, we see that an OpenFlow setup was established with 3 hosts, an OpenFlow switch and a controller. Rules are set in OpenFlow controllers such that any packet coming from host 1 will be routed to host 2, and any packet coming from host 2 will be routed to host 1. Doodoo will snippet. Rules are set in OpenFlow controllers such that any packet coming from host 1 will be routed to host 2, and any packet coming from host 2 will be routed to host 1. If we ping from H1 to H2, we see that the round trip delay to be 29.9 millisecond. Now if we ping from H2 to H1, we can see the round trip delay to be 3.91 millisecond. This is due to the internal communication with that of the software controllers. This essentially confirms that our hardware content-based router is much better in delay performance.